Okay, friends, so this is the continuation of the last video, that is the video number 7, where we discussed about forecasting accuracy. And just a quick recap, the model was Winter's model, and in that model, we had three smoothing coefficients alpha, beta, and gamma, whose values were arbitrarily chosen as zero point 0.1, zero point 0.2, and zero point 0.3. And we also calculated the residuals, absolute values, squared errors, and relative measures, RSFE, MAD, and TS. And uh, as we taken averages in the last row, so this gives us the MFE, MAD, MSE, MPE, and MAPE. This much you have already seen in the last video. And also we plotted our TS values against two control limits, -2 and +2. And also we plotted the residuals against two control limits, -2 into square root of MSE and +2 into square root of MSE. And these are the plots. So the first plot is the actual versus forecast. The second one is the TS values against +-2 control limits, and the third one is the residuals against the +-2 into square root of MSE control limit. So first of all, I will make an image copy as picture from here and just place it here, because I want to compare it when the parameter optimization is done. So in parameter optimization, what we will do is we will vary these three parameters, that is the three smoothing coefficients, so that our one of our error estimate is minimized. So in this case, we will select MAD. So we will minimize the error estimate MAD. So how to do that? Go to data and solver. Remember, these optimization models have been discussed in detail in my optimization using Excel playlist. So if you are interested, please go to that playlist and check out all the videos where I have discussed both linear and non-linear models, and using Excel and solver to solve them. So in this case, this is a non-linear model, so I will use solver. So go to data and solver. By the way, if you don't find solver here under data, then you go to developer and Excel add-ins, and make sure that is this solver add-in is checked here. If this is checked, then solver will come under data. So go to data and solver. I am resetting this because I want to formulate again in front of you. So set objective. First of all, you need to set the objective. What is your objective? Your objective is MAD value. So this is the MAD value J50. So J50 is the objective which you want to minimize. So select this min. And then by changing which variable cells? By changing these three. So by changing these three, you want to minimize the MAD. And what are the constraint? In order to enter the constraint, go to add, and then we have only one constraint, that is these coefficients should be less than or equal to 1. Also they should be greater than or equal to 0, but that you don't have to enter, because if you check this, it will be automatically made sure that these three are greater than or equal to 0. Then in the solving method, make sure that you select the GRG nonlinear, because this is a nonlinear problem, and that's all you have to select here. After that, you will just click on solve. So if you click on solve, then you see that the graph changes. So this was the before. I have already made a copy in image form here, so just compare it. See here, the forecast is almost very good in match with the actual, not perfectly match obviously, but better than this one. The TS values are also, some of the TS values are within the +-2 range. Here it was too poor, but it is not too poor now. It is better than this one. The residuals also, most of the residuals are not above the zero line, as in this case. The residuals are almost equally spread. between the above and below of the zero line. So therefore we will say that by doing this parameter optimization, we were able to improve the accuracy of the forecasting system. Still it is not perfect, but it is better than the previous one. So now I want to discuss the benefit of having this parameter optimization process. So there are two benefits. The first one is pretty much obvious, that is, it is minimizing the error and therefore improving the forecasting accuracy. In the second benefit, it is little subtle, so let us understand it well. We have seen three methods: Winters, Holt's, and simple exponential smoothing. Winters method was for level, trend, and seasonality, all three. So Winters method was taking care of all these three components of time series. Holt's method was taking care of only level and trend, and simple exponential smoothing was for level only. So that is why we had three smoothing coefficients for Winters method, two for Holt's method, and just only one for the simple exponential smoothing. Now what I am saying here is I can only rely on only one method, that is I will only use the Winters method, and I will scrap these two. I am not going to use these two, and then I will run the parameter optimization process. So then what will happen? If I use the parameter optimization process and the time series data is such that there is no seasonality, then the parameter optimization process will itself make the gamma coefficient equal to 0, and then it will be a Holtz model. Then if the time series trend component is not present, then the parameter optimization process will make beta is equal to 0, and therefore it will only have a positive value of alpha, and this will reduce to simple exponential smoothing. Therefore what I am saying here is just work with only one model, Winters model, and apply that model to every kind of data, and then use the parameter optimization process like this using solver. If you do that, then if it does not have trend or seasonality, then correspondingly the beta and gamma value will be 0, and it will reduce to a lower version of the model. So the benefit is that you don't have to work with three kinds of models, just work with just one type of model. The parameter optimization itself will take care of the fact that it will reduce the model. So that's all about the parameter optimization process. You can use it using solver and Excel. And that's it. In the next video, you will see how to perform a linear regression, simple linear regression in case of time series analysis. Until then, thank you and thanks for being with me in this video.